So today I'd like to share with you some research that we've been doing at Harper Adams about the adoption of autonomous crop equipment, and Dick Godwin has been involved in some of that work, and so he can verify or question my version of those results. So on the first screen, you see there are some pictures of the various types of equipment that people envision crop robots to look like. So on the left side, you can see the retrofitted equipment from Handsfree Farm. In the middle is a vision from Simon Blackmore and his group of swarm robots, so relatively small robots working in crop fields. In the upper right, you can see a vision of large equipment that comes from one of the major equipment manufacturers. And in the lower right, you see the dot equipment from Saskatchewan. That doesn't look like anything that we commonly use in fields these days. But which one of those visions, if any of them, will become the standard for crop equipment? Which ones will be widely used? So what I'd like to do today would be to look at what might be the pathways for adoption. And what I wish I could do was to draw a chart like the one on the right side of the screen, which is a chart that we drew in the mid-90s. My students and I drew this after just a couple of years of studying some of the early precision ag tools, the variable rate fertilizer and so on. And while it wasn't accurate for any specific technology, it did capture much of what was quite an irregular adoption process, so that there were regular initial enthusiasm, discouragement because it didn't turn out to be quite what it was being hyped as. There were plateaus in adoption, and then at least for some technologies like GPS guidance, we see almost 100% adoption in some places. So we're not quite to that point yet, but what I'd like to do today is to share with you the few numbers that we have on adoption of autonomous crop equipment worldwide, to outline some of the results of the research on the economics of crop robots, to identify some of the drivers of crop robot adoption, and then hypothesize really two potential adoption paths, because our hypothesis is that the pathway to adoption may vary depending on what part of the world and what your agricultural geography looks like. So let's remind ourselves what the benefits are expected from crop robotics. And the discussion always starts with easing of farm labor constraints, and farm labor is becoming harder to find everywhere in the world. But beyond that, there's other elements and other benefits that in the end may end up being as important or even more important in given circumstances. So reducing farm equipment investment requirements. So I'll have a slide about this in a little bit, but the idea that by using smaller equipment more intensively, overall investment can be reduced. There's the idea of reducing and maybe eventually eliminating herbicide use with targeted spraying, and then other kinds of weed control. So mechanical weed control or laser, or there's a variety of other non-chemical methods. There's some ideas about biodiversity that might increase because robots can farm small, irregularly shaped fields quite efficiently without losing a lot of their economic efficiency. And then an aspect that is rarely talked about is the potential for rural entrepreneurship when labor is no longer the key constraint in agriculture. And one of the easiest to understand examples is organic production. One of the big constraints for organic production, especially in industrialized countries, is just the cost of labor for weeding and harvest and so on. If we had robots that could take some of that labor burden, then there would be many opportunities for organic production. So let's think about how they're being used right now. And they're starting to show up in fields. So the photo at the right is Robotic, an agro-intelli product from Denmark, a weeding robot that is pictured there in Stratford-on-Avon in June last year. So there's 2 of those robots in the United Kingdom now, and there's other companies that are preparing to introduce their machines. Weeding robots are being trialed all over Europe. Most numerous, they are in France, where in 2020 there were about 150 weeding robots being used mainly in vegetable and sugar beet crops. One market assessment assessed the overall agricultural robotics market worldwide at $49 billion in 2021. The Future Farming catalog of crop robots, the 2021 version, had 48 robots marketed by 31 medium and small manufacturers, so not the major farm equipment manufacturers, but other ones, plus 2 companies that had tractors that could be operated autonomously, and 6 companies with retrofit kits that would convert conventional tractors for autonomous use. And as we'll talk about in a little bit, in North America, John Deere and C&H Raven are commercializing autonomous crop equipment. On the ag retailer side, U.S. ag retailers, and this data is from the Crop Life Purdue survey that we've done for now 25 years, only a few of the retailers now use robotics. So around 4% of them in 2021 used robotic scouting, and 1% used robotic weeding. But they expect this to grow very, very substantially by 2024. So they expect by that time 16% will use robotic scouting, and 13% will use robotic weeding. And this illustrates in some ways one of the potential drivers of adoption other than lack of labor, which is weed control options. And in North America, where this data is from, the issue really is herbicide-resistant weeds. So in Illinois this summer, there was identified a weed, Palmer amaranth, that is resistant to all known soybean herbicide families. And this issue of herbicide resistance is becoming more and more common. And that leads farmers to think about, well, what are the other options for weed control, and to think about mechanical and laser and so on. In Europe, the situation is a little bit different. It's largely due to lack of chemistry, where older chemicals are not being recertified, and new chemicals aren't coming on the market because of regulatory issues. And so farmers have fewer and fewer chemical options to control weeds, so they're thinking about other alternatives. In the longer run, other issues like reducing soil compaction with small robots and other environmental benefits will also become potential drivers. So most of you, I think, know that Harper Adams has 5 years of experience producing crops with autonomous equipment. Handsfree Hectare started in 2016 with the first crop in 2017 on a rectangular hectare field just east of the campus. That was funded by Innovate UK, AHDB, and some industrial partners with converted, retrofitted conventional equipment. That was upgraded to a 35-hectare robotic farm in 2019. And there you see a field map with 5 fields that look a little more like an English farm. So irregularly shaped fields with some obstacles, some utility poles, a path through, if you look at field 1, some topography, a slightly wider variety of crops being grown: wheat, barley, oats, field beans, and cover crops, but a step toward greater reality, both on the engineering and the economic side. And to understand better understand the economic implications of crop robotics, we use the Handsfree hectare and Handsfree farm experience to estimate parameters for a linear programming model of an arable farm in the West Midlands. And one of the key ways of illustrating what some of the results are the cost curves. And you probably know that cost curves have been used by economists to look at questions of farm structure and competitiveness for many years. In a commodity-driven business, having a cost advantage is an enormous advantage. And the idea and historical evidence suggests that farmers are driven toward the size and organization of farm that would allow them to reduce costs. So in that figure with the cost curve, you see 2 cost curves: typical shape, so high cost at lower farm sizes, and then lower cost reducing as farm size increases. The blue line is the cost curve with conventional equipment, with the labels there at each node being the size of the tractor unit in the equipment set used on that farm. And as you can see, as one would expect, with larger and larger farms, larger tractors are being used. The orange curve is the cost curve with robotic equipment. And there, the label at each node is the horsepower of the robot unit and the number of units used, because we're using a swarm technology idea where as the farm area is expanded, more and more units are being used. So the first 2 sizes of farms use 1 unit. The third unit size farm, 284 hectares, uses 2 units, and the largest farm uses 3 units. And the 2 things to note about these cost curves is, number 1, the robotic cost curve is 20 to 30 pounds per ton lower than the conventional cost curve. And maybe even more importantly, the robotic cost curve tends to flatten out at a smaller farm size, meaning there's less of a economies of scale phenomena going on with the robots, which is what you would expect, because once you get up to using the capacity of 1 unit, as you expand, you just linearly add more units instead of getting bigger and bigger equipment. We also looked at how this compared to the costs of production in other countries that export wheat. And by the way, we're not, by using wheat here, we're not saying that UK farmers should grow more wheat and export wheat, but rather wheat is something that's a well-studied commodity and it's easy to make international comparisons. And so the countries that exporting wheat had production costs between 123 pounds per ton and 154 pounds per ton. And you'll note there that under that band, that colored band, there's part of the robotic, the UK robotic cost curve that lies beneath that cost of other exporting countries. Of course, as time went on, those other exporting countries would also adopt robotics, and reduce their costs. But the point here is that in addition to changes at the local farm, there's potential for changing trade relationships because you're changing price competitiveness. One of the other things that we looked at is the human supervision requirements. And we looked at that in particular because some countries and areas around the world have regulations that require human supervision of crop robots. And we thought, okay, well, what's the economic implication of that? The baseline analysis from Handsfree hectare used a 10% supervision time. So 10% of the field time was needed for human supervision, including refilling fuel, refilling seed and other inputs, and taking care of any blockages or other things that might happen. Some areas, like the state of California in the United States and the EU, depending on which country you're in, require 100% in-field human supervision. There's also the idea that maybe that human supervisor in the field might have to be there in the field all the time, but wouldn't have to pay attention to the robot all of the time, and so could use up to 50% of their time doing other things, being on the farm, on the phone, doing marketing, being on the computer, something else. Well, okay, what happens to the economics? And let's look at those cost curves again. The blue and the orange cost curves are just the ones from the previous slide. The red cost curve is the one with 50% supervision time. And that one is sort of intermediate between the conventional and the baseline robotic cost curve. Still some benefit for the robotic technology. The yellow or golden cost curve is with 100% supervision time, and there on the two smaller farms, the costs then become higher than with conventional technology. And we see that cost curve now is more steeply sloped than the conventional cost curve, meaning that the economies of scale or the benefits of having a larger farm are even more exaggerated with that 100% supervision time. So the supervision time requirement is incredibly important in determining who benefits from crop robotics and what impact it will have on the size of farms and how farms are organized. There's also the issue of remote supervision and how trouble-free or troublesome those robots are. So remote supervision of crop robots is really only economic if they are relatively trouble-free. So to look at what that meant economically, we compared those two original cost curves, the blue one and the orange one, with 4 other scenarios, 2 of them with on-site supervision, with one scenario where we assumed that there was one incident every 8-hour workday that a human being had to intervene to do something other than refill fuel and seed, or a troublesome scenario, which was 10 times in an 8-hour workday. And we don't know if 1 or 10 is really the right number. It's just, okay, lacking other data, we chose those to illustrate. And then we did the same thing with remote supervision, assuming that roughly it would take the supervisor about a half hour to get out to the, to get away from whatever else they were doing, get out to the field and take care of whatever the problem was. For the on-site, for the trouble-free scenarios, so scenarios 1 and 3, you can see there those cost curves are slightly above the baseline robotic cost curve, but not that much. It doesn't really change the interpretation of what's going on. With on-site supervision of a troublesome robot where there's lots of incidents, then there's still some benefit for the smaller farms, but for the larger two farm sizes, it's almost the same or slightly more expensive to produce wheat with the robotic scenario. And then with remote troublesome scenario, so troublesome robot that needs lots of attention, where we're trying to supervise that remotely, this is not economic. This is the farmer would be much better off just using conventional technology in that case. So we find that the optimal human supervision depends on, among other things, the number of incidents in any given day, the location of the supervisor, and the number of crop robots that are used in the field. Because if there are multiple robots being used in the field, then sometimes the human supervisor may economize on the number of trips made, even if they're operating remotely. We also looked at what impact field size has on the cost curves. And this is based on the idea and lots of evidence in many countries that farming small fields increases animal and plant biodiversity. In the UK, small fields tend to have hedges or field edges around them where you have a variety of plants and animals that live. But with conventional mechanization, that's not very popular with farmers because it increases costs very substantially. So we said, okay, what impact does that have on the economics? And again, we looked at those wheat cost curves. The blue and the orange lines in this figure are the same ones from the previous charts. And we looked at a farm composed of 1 hectare fields, which is, even in the UK, is quite small, and 10 hectare fields. And we looked at 10 hectares because, at least in our analysis, once you get beyond 10 hectares, the benefits from a field efficiency standpoint of increasing field size become pretty modest. So we compared 1 and 10 hectare fields for, again, the same sizes of farms. And we find out that with robotic technology, it really doesn't affect much. So you can see the green line with the 1 hectare autonomous equipment, and the yellow line with the 10 hectare fields with autonomous equipment, and they're almost the same as the original baseline cost curves. In the conventional case, there with the 10 hectare fields, the cost curve is quite similar to what we saw in the baseline, but with the 1 hectare field, the darker blue line, we see that the costs are substantially higher than they were with the conventional, and again, substantially higher than with the robotic. And we see that the type of, or the size of equipment, the big equipment, even the 150 horsepower and 296 horsepower tractor and corresponding combines, are no longer efficient. And we assume here in this analysis that labor can be hired to operate these small tractors on those small fields, which is maybe questionable, but if they could, that's what would be chosen as the most efficient use. So there is the potential here for the UK to achieve some of its environmental goals in terms of increasing field biodiversity without sacrificing economic competitiveness by using crop robots. This slide is the one that farmers usually are most interested in when I talk about this with farm groups. And it shows the investment required on various sizes of farms with conventional and robotic equipment. For the 2 smallest farm sizes in our study, the cost of the robotic equipment is slightly higher. So the orange bar, the robotic equipment, is slightly higher than the blue bar, which is the conventional equipment, because of the cost of the hardware and software required to retrofit for autonomy. With the larger two farm sizes, the cost of the robotic equipment is substantially less because we're using smaller equipment more intensively. We're using it more hours a day, and potentially we might even be using it more days out of the year. And so we have less need for investment in the robotic case. So we see now that there's some economics which suggest that there would be an economic interest in adopting crop robots in the UK, and I'll add here there's a parallel set of studies that have gone on at the University of Kentucky, which suggests that for Middle Western maize and soybean farms, we find some of the same results and same economic interest in robotics, but looking at legal and regulatory issues suggests that they may be one of the major constraints to adoption. In the US, there are no federal laws which currently limit use of autonomous crop equipment, but in California, OSHA, the Occupational Safe and Health Administration, which is similar like the HSE in Britain, requires that all self-propelled equipment, agricultural equipment, have an operator on site. And for remote operation, that is, if the operator is not directly behind the steering wheel, that equipment must not move faster than 2 miles an hour. And these rules are a couple of decades old, and they were made with an earlier set of technology. They were made before GPS guidance, and they were made when farmers were trying to use furrow or other mechanical guidance. And the photo of the black welder tomato harvester in the 60s in California gives you sort of a visual impression. The driver is at the wheel of that particular bit of equipment, but in some cases, farmers wanted the driver to also function as a foreman to manage the workers there that are sorting tomatoes, and didn't want him or her behind the wheel. And so there were some accidents, and OSHA came up with the rules, which they have been very adamant about protecting. The Agricultural Machinery Association has tried to find some changes to those rules, propose those, which have been rejected up to this point, although they have granted some waivers primarily for pesticide application equipment, with the argument that it was safer for the workers not to be on the equipment when the pesticides were being applied. In the EU, the Machinery Directive governs all EU machinery use, and also is used in some non-EU European countries like Switzerland and Norway. The interpretation of the current directive varies from country to country, but the driver and control requirement has been usually interpreted as having a human operator on site. There is now a proposed revision to that directive because that, among other things, that driver and control requirement led to some distortions in technology development. So there's a revision that was published in April of last year. It's now being revised and expected to take effect in late 2024. It includes application to autonomous crop equipment, because autonomous crop equipment is not used on public roads. So it doesn't apply to tractors because they're considered road equipment under the EU type approval rules. Remote supervision is allowed for autonomous farm equipment with appropriate safety precautions, obstacle detection, and so on, and retrofitting of conventional tractors for hybrid and mechanical autonomous use is okay if the original tractor had EU type approval. So one of the things that happened was that Farm Droid, which you see in the photo there, which is again a Danish robot designed for weeding and seeding, was registered in Germany under the standards for industrial trucks because that standard did not require on-site supervision. But the issue there was that it had an even slower speed limit, 0.8 kilometers an hour, than the California 2-mile-per-hour speed limit. One of the other things that happened is that Robotics, the Swiss manufacturer, which is one of the oldest manufacturers of robotic weeding equipment, introduced a tractor-mounted version, which you see there in the photo, because, and they said this on their social media, that they couldn't sell robotic versions in Europe because of the EU Machinery Directive. Some companies are focusing on swarm robotic strategies. So you have multiple robots in a single field where you can justify having a human out there to supervise multiple robots. And that's mostly of interest in places with larger fields, which in many cases are in Eastern Europe. Other companies have worked on leader-follower systems where the leader equipment has a human driver, and then the following equipment is autonomous. In Australia, there's been a lot of development, particularly of pesticide application robots like the Swarm Farms robot in the photo. They have developed an autonomous equipment code of practice. And this was developed privately by Grain Producers Australia, the Society of Precision Agriculture Australia, and the Tractor and Machinery Association of Australia. This was published in June last year. It's a code of practice, not a law. It's a code of practice to guide achievement of the standards of the Safe Work Australia Model Work and Health and Safety Law. In Australia, codes of practice are admissible in court, and they show that a business has been following best practices as far as they're known. The model they're trying to follow is the model of the code of practice in the autonomous mining industry. So autonomous mining equipment has been used in Western Australia since 2008. They have a code of practice which has been widely accepted in Australia and has been emulated around the world. It's important to note that the Australian code of practice is only intended for in-field, on-farm use, not for public roads. British Standards is developing a UK farm robot code of practice. And a lot of this grows out of work and meetings at Harper Adams, where the stakeholders in crop robots use. So farmers, startup companies, equipment manufacturers have said that it's better to have, that they need guidelines on the use. So there's lots of standards for designing and engineering crop robots, but very little for how to actually use them. Currently, crop robots in Britain, the development is carried out under research rules that require on-site human supervision, and we know what implications that has for economics. We don't know how much of the EU Machinery Directive will be carried over into UK law and regulation. The Australian code of practice is not very well suited for Britain because the conditions are so much different. That in the outback in Australia, if a robot malfunctions, the chances of a human being injured or killed are modest. There's not very many people out there. The British countryside is quite crowded, and so the conflict and the potential for human injury and death is much higher. And there's a feeling that it's better to have private guidelines developed rather than those guidelines being imposed by government, or at least even if the government regulations are implemented, they at least have some sense of what the industry would find useful and acceptable. Some of the issues that are being considered in the Code of Practice, and we start the drafting next week. Some of those issues are the human supervision requirement under different circumstances. So is that human supervision on site? Is it remote? How big is that robot? What is the size of the robot? Because most people think that for very small robots, human supervision may be very light. So no one much cares about the little robot vacuum cleaners or robot lawnmowers. But having a 300 horsepower autonomous tractor could cause considerable damage if it ran amok. And so having more human supervision is thought reasonable in that case. What field speeds might be appropriate? What training would be required of human supervisors of crop robots? What should the site preparation look like? Should there be signage, fencing? Should neighbors be alerted? Should everybody who usually walks their dog in the area get a text message when the robots are functioning there? You know, what kind of preparation should there be? How should human robot incidents be reported? How should robots be managed for environmental protection? How should theft of robots be prevented? And particularly for small robots, if they're operating in remote fields and are not subject to on-site human supervision, what's to prevent somebody from nicking robots? In the Australian Code of Practice, fire prevention is an issue. That may be less of an issue in the UK. So let's think about that adoption path. With that background, let's think about adoption path for field crop robots. And after spending a couple of years looking at the economics and how this compares to the adoption of other agricultural technologies, we think that for the arable production sector, grains and oil seeds, in places where they have large rectangular fields that are well adapted to conventional mechanization. So we're thinking of US, Canada, Brazil, Argentina, Australia. Co-robotic automation of large equipment makes a lot of sense. And we see now that that's in fact occurring. So in the photo there, we see a tractor and grain cart equipped with the C&H Raven OmniDrive adapter kits, where there's a human operator in the combine. The grain cart is autonomous and syncs itself with the combine to allow on-the-go unloading. For field crops in areas with small irregularly shaped fields, so this is most of Europe, Eastern US, South Asia, we think small and medium scale autonomous equipment makes more sense. Some flexibility in supervision is probably required for that to become used on a widespread basis. For field horticultural crops, automation will occur as engineering problems are solved. So the economics are really, really clear. And the labor issues are really driving a lot of horticultural interest. But there's a lot of engineering issues to be solved, whereas in the arable crop sector, that was mostly mechanized decades ago. So we understand how to mechanize it. And so the issue was just how to make it autonomous. In the horticultural sector, the mechanization wasn't solved for many crops. And so there's engineering issues that need to be resolved. So why is co-robotics a likely solution in areas with large rectangular fields? One element is that robotics doesn't totally eliminate economies of scale. For example, it costs roughly the same for autonomy hardware and software for equipment of any size. So the GPS unit and the software is about the same for a 38 horsepower tractor and a 300 horsepower tractor. Safety concerns tend to increase with larger equipment, so it's more likely that on-site human supervisors will be required with larger equipment. So having co-robotics and having someone, a human there, makes a lot of sense. And then the traditional equipment supply chain is well established. It could adapt more easily to co-robotics than to autonomous equipment. In the photo there is the leader-follower system that has been developed by Fendt, the German manufacturer, with a human driver in the first tractor and then the second tractor being autonomous, and that satisfies the EU current human supervision requirements. You probably saw that John Deere is planning to market its 8R autonomous tractor sometime later this year. This fits their economic, legal, and business case. But when I saw it, I said, will farmers use it as John Deere intends? And so if we think about it, the large autonomous tractor fits the current John Deere business model. This is exactly what Clayton Christensen predicted in The Innovator's Dilemma, where he pointed out that in many cases, large companies will respond to their current customer base, and the current customer base for a lot of the best Deere customers is for large tractors and large equipment. And they will miss opportunities to serve, to use new technology that may serve a different kind of customer. Tillage, which is where the 8R is initially intended to be used, is one of the most trouble-free of field operations, and so requires the least human supervision. So if you think back about that chart about the cost curves with different levels of incidents, we note, okay, robotics makes sense if it can be relatively trouble-free. The market for this equipment is in US states and Canadian provinces where there's very little or no regulation of crop robotics. The big market probably isn't in California, where there is. But will farmers choose to use this equipment remotely or with on-site supervision? So I can imagine a Midwestern or a Great Plains farmer planting corn or seeding wheat in a field where there's an autonomous tractor going ahead of the planter or the seeder preparing the soil. I have a little bit more difficulty imagining a farmer leaving the 8R tractor operating through the night tilling a field, but maybe with experience and growing confidence that will happen. One of the other comments that I heard when this was announced was, why in the world would John Deere announce the autonomous tractor at the Consumer Electronics Show in Las Vegas instead of at an agricultural event? Certainly, Farm Progress Show or Agritechnica or another agricultural show, the Louisville Farm Equipment Show, would have many more potential customers than CES. And so it raises the question of, is this really a publicity stunt? So last slide here, the take-home message is that crop robots are in the commercial pipeline and they're starting to be marketed. Robotics have the potential to be as disruptive a technology for agriculture as motorized mechanization was in the early 20th century. So all the changes in farm size and farm structure and so on that mechanization led to, we could see another round of that with very different results. Legal and regulatory requirements are probably the major unknown in commercialization of the technology. And crop robotics may be the low-hanging fruit in farm automation because grains and oilseeds are already mechanized. And Handsfree hectare shows that autonomy is technically feasible and less expensive than many people thought. And an image to leave you with in terms of the regulatory requirements. The photo there is one of the Robotics weeding robots with a human watching it. And the question is, what danger would that robot pose if it were not watched? And so with that, I'll leave you. There's a slide there for those of you who like to see things in written form. There's a number of articles and papers that we've put out in this area. So thank you very much for your attention, and I look forward to your comments and questions.
Fine, thank you very much indeed, James. If you want to unmute yourself, you could, if you wish, give James a clap for that. Anybody wanting to? Unmute yourself. Many thanks, James. Much appreciated. If you can mute yourself again, please. James, I've got 3 questions. No, I've got perhaps 4 questions down here. Could I just open with, you're well aware that we receive a large number of research papers into the journal, into precision agriculture, on robotic ripe fruit detection. Do you think that robotic fruit detection is going to be the limiting factor in the uptake of automation in horticultural crops or high value crops?
Certainly, both having been the editor of many of those manuscripts, and also having talked to my colleagues at Harper, that developing a robot that can detect ripe fruit and pick it without damaging it is a real engineering challenge. There is some equipment, and if you look at the Future Farming crop robot catalog, there are a couple of robots on the market that claim to be able to do this, but it is a real challenge. And we've also seen just in this last year a couple of the California-based startups close because they just basically admitted they couldn't do it on develop the technology on an economic basis. So this is a real challenge that will probably take a few more years to really resolve.
Thank you, thank you. We've got a question from Tim Reynolds. What role is the scouting role of the robot?
So there's quite a number of companies that are in the process of developing scouting robots, and I think it's because scouting is easier than actually picking fruit or harvesting grain or seeding or a lot of other farm tasks. But the scouting robots often will collect images. They will, some of them, take soil samples. They may in fact attract insects, be able to take leaf samples for plant diseases and so on. And in many cases, they then target and help the human scout target where they will focus their attention. So there's a limit on what you can do, certainly with satellites from outer space. UAVs make that a little better. You can get higher resolution, but you can get even more resolution with a scouting robot. And so there is some potential there. I don't think there's as much potential as the amount of venture capital that's going into it right now. It's done for marketing reasons to have an early product on the market rather than for the real being the real driving force.
Okay, thank you, James. I don't know whether Tim Reynolds want to follow up. If you have, please unmute yourself.
Thank you for that.
Any follow-up? No. Okay. A question from Shaman. In the cost curve graph, what duties is the robot undertaking in the crop production system?
So we follow the Handsfree farm model where all of the operations are handled robotically. And This is a farm with direct seeding, so there isn't tillage, but the crop is seeded. All of the crop protection chemicals are applied robotically, fertilizer is applied robotically, and the harvest is done with autonomous equipment. So all of the crop operations are handled by autonomous equipment.
Can I just come back on that?
Sure.
I can't, in terms of the size of the harvester, I can't believe that can compete with the output from conventional harvesters that are around today. I mean, the harvesting operation, if you look at the economics of a farming system, is very highly dependent upon the harvest work rate. And if you compromise that in any way, you very quickly compromise your economics of your farm. So is that truly competitive in terms of work rate?
It's competitive, remembering that you're not comparing one combine to one robot. You're comparing one combine to several harvesting robots.
Right.
And
right.
when you think about, okay, on Handsfree Farm, what we have is a cloth combine with a 2-meter head, which on the market in India, where it was built, sells for around 30,000 pounds. In a combine and so in order to achieve the same output as a 300,000 pound combine, larger combine, you would need 3 of them. Okay, you can easily buy 3 of them for the cost of that larger combine and still come up with some of that equipment savings. So yes, it is possible if you remember you're using multiple units, not just one, because you're not depending on one human on each combine. One human might supervise several of them.
Mm-hmm.
Yeah, thank you.
Okay, thank you, Tim. Question from Alan Plom. How is supervision, in quotes, defined? Presumably on screen, quotes.
Not necessarily. So it depends. In California and in many EU countries under the Machinery Directive, the human has to be on site in the field, basically like the drone regulations, where there has to be a line of sight to that robot. The question then is, could we use remote supervision, which is what Deere is advertising for their R8 robot. It's what Sabanto, a North American company that produces a retrofit kit, and others have advocated. And so what supervision means is one of those issues that will be taken up in the UK Autonomous Equipment Code of Practice. And probably it means something different in different circumstances with different sets of equipment.
Shall I come back on that?
You can do that, Alan.
Hello, James. I don't think we've met before. I usually take the role of pricking everybody's health and safety conscience in these things, as I spent about 35 years with HSE. Okay. And in agricultural safety section, I was head of that when for 9 years. So my colleagues are the ones that you're liaising with, or my ex-colleagues, I think. I jumped in one slide too early with that question about supervision, because you then went into it in some detail and picked up on it later, particularly on the John Deere slide as well, you know, and the last one. So really, I suppose my question is about your current discussions. I missed, unfortunately, the presentation on the development of the BSI committee a week or so ago. I've just moved house and had all sorts of problems. That's another story, but I've yet to watch that. And I assume a lot of this information was discussed during that meeting?
Yeah. So there was and in fact, some of the slides are the same. And so you'll see that, but several, HSE has been an active participant in those discussions. They came to Harper to meet with the Handsfree Farm team to get a better understanding of what the issues were and what's proposed. And so, I mean, I and British Standards, we hope that we can come up with something that's both workable for farmers and agribusiness people and satisfies the health and safety concerns, because no one wants dangerous equipment out there.
No. And I can see, I wasn't a Brexiteer, but I can see post-Brexit an advantage for the UK legislators. We've traditionally adopted in UK a risk-based approach to regulation, or to certainly application of regulation. So it is risk-based, whereas certainly in the early days of the Machinery Directive, it was okay. Here's a hazard. We've got to protect whatever. And it was very simplistically written, and that's caused a lot of grief in terms of this type of equipment coming in. And I foresaw that in my time in HSE. I left in 2011. I kept saying, look, guys, look over the horizon. This is nearly with us. We need to do something. So am I right that my ex-colleagues now are taking a more fundamentally risk-based approach towards supervision? And it sounds like they are.
Yes, and that's very correct, and they emphasize that to us when we've interacted with them.
That's good. Positive news for the sector. Yeah.
Well, it's positive news for the UK, and so behind a lot of this is this thinking that the UK was once a major exporter of agricultural equipment. When I started traveling internationally, if you saw a tractor in Africa or South Asia, it was probably a Massey Ferguson 35, and it may have been built in Coventry. Well, okay, the UK has lost that market, but could it be an exporter of robotic farm equipment? Okay, this could happen, but it will only happen if that industry grows in the UK, and is usable here, and there's a model for using it safely and effectively.
Yeah, thank you.
Okay, thanks, Alan. That's the end of the questions. Although I guess this is a bit of information, is it, Dave O'Neill? You put up Agritechnica is now delayed until November 23 rather.
Yeah, that was Dave Tinker actually logged that up.
Was it? Sorry, it just says Dave.
It is a bit of because I had the same question when I saw it come up particularly on the BBC website. But why are they promoting it at CES? And I thought, well, actually, Agritechnica is now delayed for so long. Probably also, you're after a particularly small market of very first adopters. You don't want every farmer knowing about it too early and in too depth and turning up at their dealer and saying, I want one of these. And they say, well, you can't have one because we're not making them fast enough. We haven't got the laws and regulations in place. So go in and wait. And I thought, actually, the CES is probably a pretty good PR move, especially when you see it was all over the BBC website and loads of other websites. So they've got loads of advertising for no cost. Well, for the price of a stand at CES. Okay, so that was just my comment on that.
Okay, well, but farmers do know about it. It's been in every farm news feed, certainly in the U.S. and Canada. But you're correct that they're going to roll that out slowly, is my suspicion.
Is there anybody else who's got a question? If you'd like to unmute yourself. I've taken down a list of all those who've attended. We've got 18, including James, which is good. We've got someone called Me, and I don't know who that is. If they want to let me know who Me is.
Yeah, my name's Will. I'm hoping to do the mechatronics course at Harper Adams this year, if it's going to run, that is. So I'm quite interested in all of this autonomy that's going on. So, and great presentation, James. Thanks very much.
Thank you. What do you say your name was?
It's Will Campbell.
Will Campbell. Thanks very much. Good to have you here with us. Sorry, so no other questions? No.
One other question then.
Alan.
Thank you. You raised the issue of the fire risk. Again, it's going to depend on the operation. I think we were mindful many years ago, we had a presentation on remote control. Robotics is a wrong expression because it's really remote control mowers for working on slopes. And I've heard of quite a few of those that have caught fire at sort of, 45k a pop. It's been some expensive losses. So I guess it'll be more in terms of potential for harvesting equipment, obviously, rather than cultivation and so on.
Yeah.
Okay. Any other questions? And if not, then thank you very much all for attending, and thank you most of all, James, for your very interesting talk. Helps us a lot. I do appreciate it. So can we perhaps give James a round of applause again?
Yeah, thank you very much.
My pleasure, and contact me if you have think of any other questions.